Okay, so last class, when we're given an equation, quadratic equation, we could calculate the vertex, right? So one way of doing this before was back in the self-study lesson. We watched Mr. Khan do it. Getting the vertex, we could have factored it, figure our x-intercepts by factoring, calculate axis symmetry. So there's a lot of process there. Last class we learned that if we try to complete the square, put it into vertex form, then we can easily take off the vertex. So here we get y is equal to x squared plus 6x minus 16, right? So here we're looking at x squared plus 6x. Is x squared a perfect square? Right? It is. We don't have a coefficient in front of there, so we don't need to do anything with it. So what value do I need here to make that a perfect square? How do we get 9? What was the formula we used again?
Plus 9 minus 9.
Yeah, we take this number, we divide by 2, and we square it, right? So that's 3 squared is equal to 9. So we know that we have to add 9 to this, but we just can't add 9. We have to keep the equation true, so we have to subtract 9 at the same time. Now the whole idea of adding that 9 was so that we could turn this into a perfect square trinomial. So x plus 3, 20 squared. And what's minus 9 minus 16? How can we simplify that? That gives us minus 25. So doing this does not answer the question. The question is, what is the vertex? So if you left it like that, if this question is out of 2, you get 1. If it's out of 3, then you only get 2. You need to answer the question. Therefore, the vertex is, sorry, right?
-3,
Good. Alright? So we did a homework cleaning square. This gets into the habit. It's kind of easy to do. It's an easy process. Second question, what are the x-intercepts, right? The only way we figure out the x-intercepts in this course, in this grade so far, is by our favorite F-letter word, grade 10. Actually, it's the second favorite. I know your favorite F-letter word is fractions. Right? That's your favorite F-letter word. The second favorite F-letter word is
Function.
Fun.
fun. That's actually the third. Right? 6 letters need to factor. Right?
Yeah,
So the whole idea is what's special when it's crossing the x-intercept? What does that mean when a parabola crosses the x-intercepts? Yeah, it's crossing the x-axis, which means that y is equal to 0. So the whole idea of factoring is, so let me ask you a side question. I want you to figure this out as fast as you can. Solve this. What is
12.
2, 3, 9, 8, 6 times 5, 4, 9, 1, 2, 8, 5 times 693
This is some sort
times 0.
You want
Zero.
0.
9.
Whoa.
What
Wow,
else?
that's good.
Thank God.
So what we're trying to say is if you multiply, we have a whole bunch of things multiply together, which they're called factors, right? Things being multiplied together, they're called factors. If one of your factors is 0, then everything is 0. Okay? So that's what we're trying to aim for here. When we say, well, the x-intercepts, that means y is equal to 0. So if we know that y is equal to 0, right? If we could get this into factored form, then one of those factors, if they equal to 0, our equation would equal to 0. Okay? So the question is, how do we get that into factored form?
Foil.
Not quite FOIL, PSI, so I'm going to start using that term as well. Right? So what is the product? 1 times negative 16, what do we get?
16.
1 times negative 16.
Oh,
Negative 16. What's our sum? What do these numbers have to add up to?
6.
6. right? And so what two integers, we multiply them together gives us negative 16,
Yes.
but add up to 6.
No, why not make it add up to
8 and negative.
We're going back to original equation. We're going back to original equation, right? Our standard form, which is a squared plus b squared, so a squared plus bx plus c, which is factored. It's like all of unit 5. That's what we spent this time factoring. So what's two numbers that multiply negative 16 but add up to 6? Thank you. So the magic numbers are 8 and negative 2. So I'm going to decompose this. So x squared plus 8x minus 2x, right? That's what we want, the 8 and negative 2. We're breaking up the 6x for that, and we get minus 16. So we're going to group this, and then factor it on x plus 8. What am I looking to factor out of this part? What do I want to factor out of there?
2.
Negative 2, right? So I get negative 2, so I get x plus 8. So now I see that I have my common binomial in there. So we're going to factor that out. And now I'm left with x minus 2. And now if I know if any one of those equals 0, my equation will be true, will be equal to 0. So here we get x plus 8 is equal to 0 or x minus 2. Oops. X minus 2 is equal to 0. So therefore x is negative 8 or x is equal to 2. So therefore my x-intercepts are what? X-intercepts are, so x-intercepts are coordinates, right? So what's the coordinates of my, what are my two x-intercepts then?
8.
No. It's negative 8, so when, when x is 8, plug it back into original equation, what do we get? Well, 8 squared is 64. Sorry, yeah, negative 8 squared is 64 plus 6 times negative 8, so I'm subtracting 48, so 64 minus 48 is 16, okay? Subtract 16, we get 0. And that makes sense, right? That's what x-intercepts are. We plug in this value for x, our solution should be 0.
What if it was 2? Do the same thing or no?
Well, let's do the same thing. What's 2 squared?
4.
4 plus 2 times 6 times 2 is 12. So 4 plus 12 is 16. Minus 16, we get 0. So that's how you kind of check that we get our x-intercepts correct. Another way of saying this is that these are the zeros or roots, okay, are negative 8 and 2. So all three things mean the same thing: x-intercepts, zeros, and roots. It was just a different way of saying and expressing it. So when we talk about zeros and roots, we just talk about the x values. It's implied that y is equal to 0. Okay, so we just say the roots are negative 8 and 2. Cool? Make sense? Questions? Okay, now I'm going to show you something funky. And actually, when I was looking at Jordan and Amy, they were on the right track. Oh, no. Not yet. What happened to my thing?
I'll go after. Who's Alan? We wrote it.
Okay, so we saw that this equation, this was the same thing as x plus 3 quantity squared minus 25, right? We did complete the square. These two equations are equivalent, or similar. But what does x-intercept mean again? Y is equal to 0, right? X-axis. So we basically want to solve, well, when y is equal to 0, we want to solve for x. In other words, what value of x in this equation will give us 0? Well, back in grade 9, if you were given an equation, 0 is equal to y minus 25, how would you solve for y? Isolate for y, great. Exactly. How do we isolate for y in this case?
Subtract it.
Add 25.
Yeah, we want to add 25 to each side. Oops. And then basically get y is equal to 25. Right?
Just bring the 25 over.
We don't move things in math. Not about math. Math not about magically moving things. What we really do is adding 25 to each side, so that get rid of the negative 25 on the right hand.
Do we have to show that?
You don't have to show it, but I want to make sure that people understand the concept. We're not really moving things. I had to dispel that rumor with my grade 9s. They think, and all of a sudden they're just moving things all over the place. That made absolutely no sense. So I want to make sure that we're not moving things, we're adding 25 to each side. So here what we want to do is we want to isolate for the square, the thing that's being squared. So we want to do the same thing. So here we're going to add 25 to each side. So we're left with x plus 3 quantity squared. Okay, so we isolated for our square. We want to isolate for that. So now that we have a square on one side and something else on the other, how can I undo the square? Or what is the opposite of squaring?
Square root.
Michael?
Square root of
Thank you. So you do the square root. So if we do the square root of this, well, what we get here is x plus 3. That's the whole idea of us taking the square root of it, so that we get rid of the square. We're just left with x plus 3. Square root of 25. Right? Yes?
What are we trying to find there?
We're trying to isolate for x. We want to solve for x.
But what does x represent in this? Oh, x.
Well, the x is representing, just like in our quadratic equation, any value. But here, we want to know what value of x will make y 0. Right? X is just part of our quadratic equation. Right? So similar to the basketball question, right? When x was 40, how high did you have to put the cup? You solve for it, right? Well, here we want to know when y is 0. How can we know what value of x will give us 0? So I have a question. Is 5 the only number that you can multiply by itself to give us 25? I see yes, I see no.
Yes.
Maybe, yeah.
Yes.
Well, what other number can you multiply by itself other than 5 to give us 25?
Yeah.
Negative 5 as well, right? So really the answer to the square root of 25 is plus or minus 5. So that's how you write that. Okay? So now that we have the answers plus or minus 5, how do I isolate for x? How do I isolate for x?
3. You put minus 3.
We subtract 3 from both sides. So now we have x is equal to negative 3 plus or minus 5. In other words, we have x is equal to minus 3 plus 5, or x is equal to minus 3 minus 5. So here x is 2, or x is minus 8. Is this not the same answer that we got over here? We have x is equal to negative 8 or 2, right? Doing it a different way, we get the same answer. In other words, two different ways to figure out what values of x, in this case it was 2, so that that equation gives us 0. Yes, Jordan?
If the 25 wasn't like a square, what would you do?
We'll talk about that in a bit. Okay?
By getting to get 25 on the left side, would you just like take out the? Like,
Well, I added 25 to both sides.
Okay.
So when I added 25 to here, it got rid of it, but now I look at 25 on the other side.
Then
Okay.
what's that on the right?
This is just me reflecting back to grade 9. How would you solve for this?
Oh, okay.
How would you solve for y? Right? And here basically it's the same idea. You added 25 both sides, we get y. So we're isolating for y. On this part, what we were doing for was we were isolating for this square. Okay? Before we could take the square root. So you need to isolate for that square part before you can take the square root of it. That's important. That's why we had to add 25 to it first, to get rid of that negative 25. Okay? So really now you have two methods to figure out the x-intercepts. You got to factor, or you could try to complete the square, and then going this way. Which way is better?
This way.
Personal preference, right? I like to factor. You like to factor, we try to factor, you like to complete the square. But now you have another tool in your repertoire, right? So question. Find the roots that is solved, right? So that's another way of talking about things, solving for an equation, right? Find the roots of this equation. So how about we try to do this?
Bring it all to one side.
Bring it all to one side, okay? So how are we going to do that, Jordan?
I'd say add 27 to both
So
sides.
we add 27 to both sides. And what happens to the other side?
Goes to 0.
Well, equals to that magic number again, 0. So if we got something equal to 0, what can we try to do then? To find out what value of x is going to make that equation 0. Liz?
Like isolate x?
Well, we could try it, but now we got everything equal to 0. What's that magic thing that we did, right? Over here that we discovered that if we do what to our equation will give us 0.
Multiply by 0.
Well, we can't just multiply by 0. It's not gonna,
As a 0.
yeah, so we want to factor this. If we can factor this, get a bunch of things multiplied together, then that'll give us a 0. So PSI, what's our product here? We have an implicit 1 times 27 gives us 27. Our sum is negative 12, right? So what two numbers multiplied to 27 adds up to negative 12?
Negative 9, negative 3.
Thank you. So negative 9, negative 3. So we have, I'm going to decompose this now, x squared minus 3x minus 9x plus 27 is equal to 0. Right? That's the whole idea of us decomposing it. We're getting those two numbers. Factor on x, so we get x minus 3. We're going to factor on 9. So I get x minus 3 is equal to 0. So now I get x minus 3 times x minus 9 is equal to 0. Right? That's why we spent the whole unit factoring. Just so we can get here, Then we can say x minus 3 is equal to 0, or x minus 9 is equal to 0. We'll make that whole thing 0. So therefore, we get x is equal to negative 3, or x is equal to 3. Or x is equal to 9. So in other words, when x is equal to 3, or x is equal to 9, we will get negative 27. So let's do it in our heads. What's 3 squared?
9.
9. What's 3 times 12?
36.
So what's 9 minus 36?
27.
Negative 27. That works. When 9 and x is 9, what's 9 squared? 81, right? What's 12 times 9? 108. So 81 minus 108 gives us negative 27. So both of these value x makes this equation true. We solve for this equation. Question
How
on
does it turn into plus 27?
Well, because we just added 27 to both sides. So let me implicitly put this in here then. In here, right, we added 27. We added 27 to both sides.
Oh, is that an equal sign?
Yeah, sorry, there's an equal sign under there, under my green arrow. Okay, that was the original equation, x squared minus 12x is equal to negative 27. Okay, so that's one way we could do it. Here's another. X squared minus 12x is equal to negative 27. I'll put some spaces there. Guess what we're going to try to do?
Get it to 36.
What do you think you're going to try to do? Not quite squared. We're not calling squaring it. We call it
Complete the square.
complete the square to get a perfect square trinomial. So what value do we need here to make that a perfect square trinomial?
36.
Yeah, negative 12 divided by 2 gives us negative 6. Square it. We need to add 36. And I need to add 36 on this side. Because I added 36 to the left, I need to add 36 to the right. So now what left with us on the left is x minus 6 quantity squared, which is what we're looking for. So we put it there to get that binomial squared. Simplify the other side. What's minus 7 plus 26?
19.
Negative 27 plus 36? 9, right? Let's take the square root of both sides. So we have x minus 6 is equal to 9. Sorry, not 9. Square root of 9 is what?
3.
Just 3?
Or negative.
Start getting the habit. Taking a square root of a number, you get plus or minus that value. Now I want to isolate for x. So how do I isolate for x? Add 6 to both sides. So x is equal to 6 plus or minus 3. Therefore, x is equal to 6 plus 3, or x is equal to 6 minus 3. So we have x is equal to 9, or x is equal to 3. Same answer. 2 different ways to get there. So again, I ask, which technique is better?
I like the second one.
Like completing the square?
Yeah.
Yeah? It's a process a little bit. So if you like completing the square, you gotta get in that, make sure you do that completing the square homework last time. Getting that completing the square, getting those values so that we can put it in the vertex form, as we call it. Okay?
Can you go back a second?
Yeah, can I just-
How did you know to Never mind, I got it.
No, how do I know to what?
I was just confused how it's because you got x minus 6 plus or minus 3, and then And that can give you two answers, which is 9 or 3. And
Yeah, so basically, yeah, when we take the square root of 9, there's two answers, plus or minus 3, right? It's a positive and a negative value. So basically, when we brought when we're adding 6 to both sides, it's really 6 plus 3 or 6 minus 3. That's when I broke it down over here. So that's what we have, two answers. It makes sense. We have two roots there. Right? We saw that from over here when we just factor it. There are two answers. We know this quadratic is going to cross the x-axis at 2 points. Okay? So let's say I was a factoring fan. So one of the things I'm going to go off and try to calculate the zeros of this equation by factoring. Well, what two numbers multiply the 4 add up to 6? So let's say I want to do the PSI. What two integers multiply the 4 but add up to 6?
9.
Try as you might, not going to get it. Best you can do is 4 and 1 that adds up to 5. Not quite. That sucks. Well, how am I going to try to answer this question now? Complete the square. So if y is equal to x squared plus 6x plus 4, how am I going to complete the square? What do I need to add?
9.
9.
Plus 9 minus 9. So now we're left with y is equal to x plus 3, 20 squared. And how do we, what are we left with? So that was this part. So we got minus 5. So what does the 0 root mean again? What does it mean when we want to find the roots or find the zeros of this equation?
When it crosses the y-axis.
So y equals 0.
Yeah, when it crosses the x-axis, or basically y is equal to 0. So here we're going to say y is equal to 0. X plus 3, 20 squared, minus 5. So I want to isolate for the part that's squared. So how do I do that?
Add 5.
We add 5 to both sides, so I can isolate the part that's squared. And now for me to isolate for x, what is it I want to do? I want to do the opposite of squaring. I will undo the square, which is the square root. So we have the square root of 5. So here we're left with x plus 3. Square root of 5 is plus or minus the square root of 5. We're just going to leave it. It's known as a radical. Okay? We're just going to leave it in radical form. It's exact. So it's plus or minus the square root of 5. So how do I isolate for x? How do I isolate for x?
Minus 3.
How do I isolate for x? Yeah, we want to subtract 3 from both sides, so we get x by itself. So plus or minus 5, sorry. Plus or minus the square root of 5 minus 3. So therefore, x is equal to the square root of 5 minus 3, or x is equal to minus the square root of 5 minus 3. Okay? So now your answers are looking a little bit different, in that we don't have something that is a perfect square. But we're just going to leave it at, sorry? So it's still plus or minus the square root of 5, so that's why we have here,
So why,
because it's plus the square root of 5 minus 3, or the negative square root of 5 minus 3. We still have two answers,
okay.
right? Actually, this is better written as x is equal to negative 3 minus the square root of 5, or x is equal to negative 3. Sorry, this is plus the square root of 5 minus the square root of 5. Almost treat like your radical as like a variable, right? So we want to kind of stick it at the end. So 3 plus the square root of 5, or, sorry, negative 3 plus the square root of 5, or negative 3 minus the square root of 5. Those are our two answers. So you're going to need to get used to expressing your answers in what we call radical form. Okay, so that answers your question, I believe. And what happens if that number that we're taking the square root of is not a perfect square? Just leave it as the square root of a number, but it's plus or minus again. Okay, so here we see the one advantage of completing the square over factoring over integers. Sometimes it can't be factored over the integers. Okay. Any questions on this?
So if it said find the zeros and you put in the brackets, would you do negative?
Sorry, find is just put in what brackets? What is it you're trying to do?
What are the zeros be coordinates?
So if I ask for these x-intercepts,
Yeah.
right? So the x-intercepts here would be,
You can put a root, square root, plus or negative 5.
well, what's my value of x? Minus 3 plus the square root of 5, comma 0, and minus 3 minus the square root of 5, comma 0. So those are my two x-intercepts.
We just have to solve. You have to graph it, we have to solve the square
It's
root.
just the X.
If you have to graph this,
Yeah. This is a little weird.
if you had to graph it, all I would do is, well, what's my vertex?
Negative 3.
Vertex is, yes, negative 3, negative 5. So I find negative 3, negative 5 is somewhere down here. Right? Plus or minus the square root of, so get your calculators. What is that approximately?
Negative something.
With what?
Well, what's the square root of 5?
2.236067977.
Negative 0.76.
Is it still negative?
No.
What?
Are both answers still negative?
Um,
Yes, because square root of 5 is less than 3, right?
Yeah.
So it's still negative. So I would label here minus 3 minus square root of 5, comma 0, and label this as, minus 3 plus the square root of 5. And then draw my parabola. You can't be exact in your coordinates, so that's why you need to label it. You label it with these points.
I don't get why the vertex would be negative 3, negative 5.
Because
We have a vertex form right here. Right? So that's the nice thing when we do completing the square, we actually get the vertex. Okay? So this is actually a very advanced question of how to graph a parabola with radical roots. We don't need to do that. Well, I think you probably need to know for grade 11, but not for this year. Okay, just understand that our roots are radical here. So the answer we were looking for is minus 3 plus the square root of 5 or minus 3 minus the square root of 5. That's the solution to this equation. Right, so we talk about solving, making y is equal to 0. We want the roots. Okay. One last example I want to take you through. What are the zeros of this equation? I'll tell you right now, this one isn't factorable over integers as well. Okay, so we'll save that process, try it. Two numbers that multiply 39 out of 12, no such integers exist. So what I'll do is, I'll try to complete the square on this. Notice I said try to complete the square. What? Can I always complete the square of something?
no.
Can I always complete the square of something?
if it's like this, yeah.
Well, can I always complete the square of a quadratic equation?
Yeah.
Yeah. Right? I mean, I can add any number to that and subtract any number to that. So I can always do this. Unlike factoring over integers, I can't always do that. So that's one nice advantage of completing the square.
What if it's an odd number in the middle?
Well, then you need to divide it, working with fractions. If you did your homework, that's what question 11 did a lot of. 11a, I remember, was a fraction.
So you can,
Because you need to get that coefficient in your x squared to be 1. So that sometimes leaves your coefficient on your x to be a fraction. So the same thing, take that fraction, divide it by 2, square it, you're going to get a fraction. So you're adding a fraction, subtracting that same fraction. And then you're going through that, but you still complete the square on that. Okay? That was actually the homework, question 11. So for here, how can I complete the square with x squared plus 12x?
Would it still be what's it called thing with the plus and minus?
Let me see, 12 minus.
Yes, it's plus or minus, but it's when we take the square root of something that has two answers, plus or minus that value. So only we get that when you take the square root
But
of
yeah,
a
how
number.
would you find the square root of negative 3?
Jump in the gun here.
Just leave it.
First, let's complete the square.
Plus 36.
X squared plus 12x, what value do I need to add?
Plus 36.
Yeah, plus 36, so 12 divided by 2 is 6, squared is plus 36. I need to subtract 36, right? So now here's my perfect square trinomial. Okay, x plus 6, quantity squared, and minus 3. So question from here. What's the vertex?
Minus 6 minus 3.
It's plus 3.
Vertex is
Minus 6 plus 3.
minus 6 comma 3. What's
On
this?
there it's plus 3. You didn't actually-
Oh, sorry, yes. Thank you. I was jumping the gun. So it's x squared, x plus 6 squared plus 3. So our vertex is negative 6 plus 3. What's the compression stretch? Sorry? Yeah, so this compression stretch factor is just 1. Is it opening up or down?
Up.
Open up?
Yeah.
Okay, so we know a little bit about a quadratic already, right? What the parabola looks like. Has a vertex negative 6, so over to the left, up 3. This basically stands that stretch or compress, and it opens up. So let's find the roots. In other words, where does it cross the x-intercept? Well, what do we do?
So
When we solve basically what we're doing. Dale?
we subtract 3.
Well, what do we do first? What's the value of y?
Set y is 0.
Yeah, because that's where it's crossing the x-intercept, that's where y is equal to 0. So we get is equal to x plus 6, quantity squared plus 3. What's the next step I want to do? Dale?
Subtract 3.
Yeah, so I want to isolate for that squared part. Isolate, so I get negative 3 is equal to x plus 6, quantity squared. Now I want to isolate for x. And how am I going to do that? Square root both sides. So I get the square root of negative 3 for the x plus 6. How do I isolate for x? Subtract 6 from both sides. So I get negative 6. Oops, this was plus or minus the square root of negative 3. Plus or minus the square root of negative 3. So what's the square root of negative 3?
Not there.
Yeah.
Sorry?
math there.
Math error. Can you take the square root of a negative number? Well, what number, when you multiply itself, gives us a negative? When we take a positive times a positive, what do you get?
Negative 1. Wait, what?
We take a positive, we take a positive times a positive, what do you get? We take a negative times a negative, what do we get? Positive. So you cannot take a square root of a negative. There's no real number that, when you multiply by itself, gives you negative 3. No real number. So really, there are no real roots.
I mean, it's above.
Well, and you think about it, this makes sense because if we said that here's a graph And basically we said the vertex was like negative 6 comma 3, which would put us somewhere over there. It opens upwards. It never crosses the x-intercept. Sorry, it never crosses the x-axis. So therefore it has no x-intercept. So this mathematically makes sense. We don't have an answer. There is no answer. There are no real roots. So as soon as you get to this point where you take the square root of a negative number, you realize that you have no real roots. Okay? Question there.
Can you just say there are no real roots once you find out the vertex?
Well, you need to get to this point where you're saying, well, I'm taking the square root of a negative number. There's no real number to give me that, so that's where you know it's no real roots. Okay? Mathematically speaking, once you get a grade, I think 11 or maybe 12. Actually, no, they must introduce this in somewhere. There's an actual answer for this. And it's called imaginary numbers.
Just in
What?
contact.
Sorry,
So
I just can't.
And that's actually a really cool concept, and I'll introduce it to you really quick, because I think this class can handle it.
My brain's
There's an imaginary, some mathematician out there.
I have imaginary friends.
They might have had imaginary friends, but what he did was, I'm going to make up a number. This number is called the square root of negative 1. Right? Square root of negative 1, and I'm going to call that I. It's an imaginary number because this number cannot exist. It cannot exist. Right? So basically you would get minus 6 plus or minus, so here we get minus 6 plus or minus I times the square root of 3. Right? The nice thing about this is once you get to math and the levels, you get answers where you get I. Right? And you will get to some places where you actually get I times I. What's I times I?
I don't know.
I squared.
So it's negative 1.
So what is the square root of negative 1 squared? It's 1, negative 1.
Wow.
So once you get to the point where you get I squared, you get negative 1. So the nice thing about this and why this person did this was there were real life problems where you actually had to take the square root of a negative number. You did the math, but you know there had to be a solution because it was out there. He was looking at a real world problem, like figuring something out. There had to be a solution. So how can we get the math to fit? So he created this I. So eventually, you worked it all out, you get back to I squared, you have negative 1, and now you can continue with the math. Whereas before, you got stuck. Like, there's no way I can do this. So there's a quick introduction to I, imaginary numbers. I'm not going to go through this example because we're running out of time. Actually, I do. Let's do this really quick.
Are we gonna get a quiz back?
No, you don't get a quiz back, but remind me to give you other subject back you wrote before Christmas. Yes.
We get time to work on that.
No, I'm going to do this really quick. Okay?
Oh no, there's rectangles.
So left of the rectangle is 2 centimeters longer than the width. The area of the rectangle is 168 centimeters squared. Okay? So first thing you're going to do to solve this is draw a picture.
Yay.
I'm a bad
Who's my
drawer.
favorite part?
That's not Tuesday.
So draw a picture of a rectangle, right? And now you get something visually to see and associate with it, right? What do we know about this rectangle?
Length is 2 centimeters longer.
Sorry, the length is 2 centimeters longer than the width.
Yes.
So basically, I'm going to label my sides on my rectangle, and I'll have something like this, right? So I have my rectangle, and we're going back to like grade 9 solving equations. Let W equals width of rectangle, right? What do we know about the length then? What do we know about the length of this rectangle?
X equals 2.
Well, in this case, it's W plus 2, right? So we go to our equation. We guys familiar with last, right? Now we know the equation. How do we figure out the area of a rectangle?
Length times width times height.
Area is equal to what?
Length times width.
Length times width,
Oh, that's that, yeah.
right? Area of a rectangle is length times width. So here we can say, well, A is equal to L times W. But what is L really?
W plus 2.
L is really, we can say as W plus 2 times W. But what is our area? What's our area? Do we know the area?
Not the number.
W
Yeah.
squared plus 2.
We do know the number.
So we have 168, which is our area. It's equal to W plus 2 quantity times W, right? Derive this from going down, just figure out the area of a rectangle, length times width. But there was a relationship in the question that says between length and width. That relationship was the length was 2 centimeters longer, so W plus 2. So how can I solve for this now? In other words, how can I solve for W? Jordan.
Okay, so you do W squared, so W squared plus 2W.
Okay, so I'm gonna put that in math terms. We're gonna expand that, right?
Yeah.
So which is why we want to expand in unit 5. So we got 168 is equal to W squared plus W.
Can you bring 168 to the other side?
Okay. So you're gonna bring 168 to the other side and you're gonna factor it?
Wait, it's 2W.
Oh, sorry, 2W.
Yeah, then you factor it. Oh, no,
Okay.
then you complete the square.
I can get W.
So if you want to complete the square, which is what I would do in this, so what was
I
your
can
question?
get W2 plus W. I mean W squared plus 2W.
It's 2 times W and then W times W.
How I got that was basically I expanded this, right?
Okay.
So it's equal to W squared plus 2W.
I forgot about the distributed.
So if you want to complete the square, right, I would just say, well, how can I complete the square with this? What do I need to add to that?
1 minus
So I'm just going to add 1 to this side. But if I add 1 to this side, what do I need to do to the other side? No.
Plus 1 plus
Yeah, I added 1 to the right,
You have to add.
I added 1 to the... So it's different in terms of completing the square that I'm doing plus or minus the same number. I was doing that because it was on the same side of the equal sign. That's basically adding
So
0.
you're basically just skipping a step?
Yes, because you're going to have to bring that over
Yeah.
again afterwards, right?
I understand what you're gonna do.
So now I have to add 168, I need to add 1 here. So now I got 169 is equal to W plus 1 quantity squared. Take the square root of this. So I'm left with W is equal to what?
Wait, why?
Square root of 169 is
Negative.
13
That's right. That's the only one I know.
Is it negative
Memorize
one?
that one.
plus or minus negative 13. So question,
Yes.
can you actually have
Plus
a positive width? Sorry, a negative width?
Interesting.
Oh.
Not necessarily.
You can. Then it would be.
Yeah, you can, but one spot's a positive.
Sorry?
Then one spot's a positive.
You can't, I did something wrong here.
Oh, did you?
Oh, sorry,
Yeah, it's not.
I got the plus 1.
Mm.
You
W plus 1 is equal to plus or minus square root of 13. So basically here I have, I knew I did something wrong. 1, negative 1, plus or minus 13. So therefore W is equal to minus 1 minus 13, or W is equal to minus 1 plus 13.
Are you tricky?
So W is equal to either minus 14
Or
or
12.
W is equal to 12. Can we have a negative width? No, right? So once we get to practical examples, we need to make that distinction, right? That doesn't make sense. We can't have a negative width. So therefore the width is 12 centimeters, and the length is
I should write this down.
14. Doesn't the same.
14 centimeters. Cool.
When you write all of
Right.
this down.
And like you said, you just 12 was 12 times 14, 168, it works. right? So this is a practical example of how we can use solving quadratic equations for questions like this.
Once you bring in the rectangles, that's too much. I can't do it.
Area of a rectangle. What is that, Elena?
Why?
What's the area? How do you calculate
Geometry.
length times width, right?
Yeah.
My son's telling me that now because he's learning geometry in grade 5.
Aw,
No.
that's adorable.
Not really. Key concepts.
Okay.
Okay.
Hope the one makes them.
Is two factors have a product of 0. If two factors have a product of 0, then one or both factors must equal to 0.
Oh. Yeah.
Okay, and I demonstrate that with actual numerical example, right? Two factors have a product of 0, then one or both must equal to 0. So another thing that we learned was some quadratic equations can be solved by factoring. So if you like factoring, enjoy it, it's fun. I like it, sometimes it's fun. We can solve quadratic equations by factoring. Right? Especially if we recognize that it's easily factorable. I want to do that. Now factoring is nice where you don't have to actually calculate for the vertex, right? You just want to find y is equal to 0. Find the solutions to a quadratic equation is also known as the roots. That's the new terminology of the school in this unit or this lesson. Although I kind of hinted at the past, the idea of a root, the root of an equation. Okay. Basically, when that equation is 0, what is the value of that equation? So for homework, there's on Blackboard, you have a choice, right? Option 1 is number 3, 4, 5, parts of it, 6, 7, 8, 10, and 14. Or you could do 7, 8, 10, 14, which is the harder problems, and answer this question. Determine the equations of this equation. Y is equal to ax squared, that's supposed to be squared, plus bx plus c. Okay? Solving that part is a huge challenge. Alright?
Is that AX to the?
Wait.
So
Does
it's
that make,
yeah.
like, does that make that big like thing?
That's supposed to
So,
be
like,
AX.
plus or minus b. That,
That's supposed to be ax squared. For some reason, they didn't come out as squared. So it's supposed to be ax squared plus bx plus c. This homework is posted on Blackboard, so you can refer to it there as well.